Morning everyone. Assalamualaikum. Kita tunggu lagi few minutes, okay? Baru 50 orang je masuk ni.
Salam doktor.
Alright, okay. Assalamualaikum. Good morning everyone. So I don't want to wait any more longer. It's already almost 8:20. Have you gone through my video? Anyone? Or you still haven't done anything? Honestly. Just read a little bit. Alright, okay. I will review a little bit on DNS and P2P, and then after that we finish. You can go these two topics with a video that I give to you, and then by the end of the class, I will give a quiz number 3 actually. It will add on to the previous one, so you can submit the quiz by Sunday. Is it okay? Boleh ke semua?
Boleh doktor.
Ya dah.
Okay. So this is going to be very short one, class. Sorry, saya pagi-pagi ni buat sakit gigi. Okay. Alright. DNS. So the next we have looked into email, SMTP, IMMP. So next one we're going to look into DNS. So what is DNS? So like human, we have like a lot of identifiers. We can have SNN, name, passport number. Like for example, in Malaysia itself, we have the what? Nombor kad pengenalan. So this is identity, okay? Identifier. We need to identify that particular person with what kind of identity number. So internet hosts or routers, they have their own identifier, which is IP address, used for addressing datagrams. And then they have names, for example, like cs.umas.edu, unimap.edu.my, used by the human, okay? So how to map between the IP address and the name and also the vice versa, okay? So in order to map that, we use a DNS. So DNS is distributed database implemented in hierarchy of many name server. Application protocol hosts DNS server communicate to resolve the names, address and name translation. It can be core internet function implemented as application layer protocol, complexity at the network edge. Okay. So what the DNS service does is that it gives a host name to IP address translation. Okay. If you can see, host name in here is kind of text message. So it's kind of like unimap.edu.my. Okay. And the IP address is in terms of number, right? 192.168.82.9, for example. So how these two is going to understand each other, or how this unimap.edu.my in here is know that it's want to go to this IP address. So this is where the DNS come from. Okay. Hosting aliasing chronicles alias name. Mail server aliasing, load distribution, okay, replicate the web server, it means have many IP address corresponds to one name, okay. And then why we not using a centralized DNS? Saya cakap slowly sebab saya sakit gigi pula pagi ni. So single point of failure, it's give traffic volume, distance centralized database and maintenance, okay. It doesn't scale, okay, because Comcast DNS server alone have 600 BDNS queries per day. Akamai DNS server alone have 2.2 tera DNS queries per day, okay? Oh my God. Okay. Now we're talking about DNS, okay, it's like a distributed database. You have a billions of record, each simple, handle many trillions of query per day. It needs to have many more reads than writes. Okay. For matters, almost every internet transaction interact with DNS. So millisecond is counting. Organizational, physical, decentralized, millions of different organizations respond for their record. Okay. Bulletproof is reliability and security. So not so easy, okay. What the DNS do is that it is a distributed hierarchical database, okay. You have root, there are different roots. You have .com, DNS, .org, .edu, and whatever dot in at the end in here. So this is top level domain. And then after you have .com, Amazon.com, PBS.org, unimap.edu, umas.edu. So this authoritative. So if clients want IP address for www.amazon.com, this is going to be the first approximation where client queries root server to find .com DNS and then queries .com DNS server to get amazon.com and then queries amazon.com DNS server to get the IP address for Amazon, www.amazon.com. Okay. So root name server, official, it's a contact of last resort by name server that cannot resolve the name. Right? And then incredibly important internet function. So internet couldn't function without it. DNS SECs provide security, so they have authentications and message integrity that embedded in DNS. ICANN, Internet Corporations for assigned names and numbers, manage the roots of DNS domain. Okay. So basically, there's 13 logical root name servers worldwide, where each server replicate many times. For example, more than 200 servers in the US. Okay. So top-level domain or authoritative server. So top-level domain server responsible for .com, .org, .net, .edu, .aero, .jobs, museums, and all top-level country domains. For example, CN, UK, France, CE, and Japan. Network solution, authoritative register for .com, .net, TLD, educase, .edu, TLD. Okay, authorized DNS server. So this is the top one, TLD. Okay, D is authorized DNS. Organizations own DNS server, providing authoritative host name to IP mapping for organization hosts and can be maintained by organizations or services.